Hello everybody, my name is Arndt Ingendorf from SIFT Technologies in Darmstadt, Germany, and I would like to talk about real-time quantitative analysis of volatile compounds in food and packaging. We use a technology called SIFT for that purpose, and SIFT stands for Selected Ion Flow Tube Mass Spectrometry. The core of the technology is a flow tube here where we ionize trace gas compounds, and we do this with a range of reagent ions which we can select with a quadrupole so that they can ionize one by one the compounds of interest. In the backstream quadrupole, we do the analysis. We detect the intensity of the generated product ions versus the reagent ion intensity, and we can identify and readily quantify any compound of interest. A large library of 1500 compounds is used for that purpose. It contains a large range of species, hydrocarbons, aromatics, nitrogen, sulfur compounds. And this is a reference library that is matched against the data for identification and quantitation. Since we don't use any chromatography, we need a high dynamic range of our system here. And you see simultaneously analysis of benzene at 30 ppm against butadiene at 30 ppt. That covers a dynamic range of 6 orders of magnitudes and also shows the high sensitivity of the method. Conventional GCMS or LCMS usually needs significant sample preparation or time-consuming chromatography, and SIFT eliminates all of that. It doesn't need it, so that's also why we call it direct mass spectrometry. And due to that, we can do real-time monitoring of dynamic processes on the fly or high-throughput analysis. We need few minutes per sample at sub-ppb levels. We can also run chromatographically challenging compounds like aldehydes or carboxylic acids without any derivatization. And here we have been looking at the emission of volatiles from packaging as well as flavor and malodor in consumer goods. We use two technologies for that added to SIFT, either thermal extraction or headspace. And in thermal extraction, you just put a piece of the sample into the tube. You heat the tube in the TD unit, and then you can continuously measure the volatiles as they emit as a function of temperature. Here you can see a homopolymer and a copolymer evaporated from some plastic material by temperature. This is some data from a PET bottle, and we basically simulated the process of a bottle being in a car, heated up by the sun, and by temperature you see certain toxic compounds being evaporated from the PET bottle, like formaldehyde, ethylene glycol, methanol, acetaldehyde. You can also imagine how these toxic compounds may penetrate into the solvent in the bottle. We do not only look at plastic material, but also at things like paperboard. And paperboard contains a lot of volatile organic compounds from either natural source material or subsequent processing. We have been looking here at 11 paperboard samples and analyzed this with headspace SIFT in this case. Down here you can see the classic order rating from the sensory panel, and on the right side you see the chemical information that we get from the SIFT analysis. And some of these compounds are highly elevated in some of these samples that may contribute to the order of the sample, but also tells you a little bit about risks of using that kind of paperboard. We can use some discriminating compounds like methanol, hexanol, and so on to group the different samples by principal component analysis. You can see that all of these 11 samples are nicely distinguished and also within a certain group, so that shows you also something about the reproducibility of the method. So I hope I could show you the reasonable data that we can generate in very short time by SIFT-MS to judge quality and maybe improve quality of packaging material. Thank you very much for your attention.